Hello, my name is Nick Gomez, and today I'm going to be talking about the Township Tales VR World Streaming Tech. So once again, my name is Nick. I'm a senior games designer at Alta. I was formerly at Deloitte and Well Placed Cactus for quite some time, and I've been here at Alta for about 6 months working on the live game. I've over that 6 months, I've been kind of figuring out everything, learning a lot about the tools we use. So I went on quite a large journey, and hopefully I can give you some of that info today. Unfortunately, our co-founder and game director, Boromir, couldn't be with us today. He's out sick, so hopefully I can fill his shoes a little bit. So in summary, this is going to be quite a high-level overview of our current technology in place, and a bit of a story about how we got there. So I'm going to be going through a couple of things today. What's the world streaming tool? That's a good question. Why did we write our own? The journey we went on to kind of get to where we are in our tooling. Some weird stuff that happened, because that's always fun. And the lessons that we learned along the way, which will hopefully be helpful for you. If you're looking for a deep dive into our tech, how it all works, there is this excellent 3-hour video on YouTube. Boromir and our lead engineer, Victor, go through most of the game, most of the tools within it, and a lot of the really technical, weird stuff that goes on when we build and run our game. So if you're looking for something technical, I do recommend that you check that out. So first off, what's the world streaming tool? Best question to ask. So it is how we handle streaming our very large map and environment to multiple players at the same time. It's the processes and tooling we use to optimize the performance. And it's how we manage dynamic objects, AI entities, and progression within the live game environment. So it does a lot of different things, and it's quite large at this point in time. But why did we build our own? There's other things out there, right? We could have done whatever. But we needed support for both pre-made and procedural environments with a large number of dynamic entities. And we needed that to run very well. So we needed it to share the technology between our saving and our networking systems. And we needed to kind of assist with our baking and building pipelines to optimize all the static content throughout the game. And like I said before, we needed it to integrate very tightly into our bespoke networking system that our devs spent a very long time putting together, because it needs to handle so much going through it. And in a big way, we needed to be flexible. So we needed to support our game as a service style updates, and allow any of our developers to kind of jump in, make changes around the world, and then push that content without interfering with anybody else's work at the same time. And that was one of the big important factors of this thing. But really, why did we do it? So the less fancy way of saying it is that we were using Sector at the beginning, which is an excellent tool, still available on the asset store for most of our world streaming kind of use cases. But around the time our lead engineer, Victor, came aboard, there was this uncertainty that it couldn't quite tick all the boxes that we needed. And the list of those boxes was growing every day and becoming ever more complicated. And there just wasn't confidence that everything would be compatible with each other, because along this journey, we would have to be sure that everything that we wrote would mesh together. All of the systems that we needed, all of the custom tools would need to work together in a beautiful harmony. And that any tool that we needed could be implemented in a smooth way, and could be usable, and there would be no incompatibilities in the system. Our tooling journey. So at first, the world streaming tool was used basically just for loading and unloading for performance sake. So we were using Sector for the most part in that beginning. And when we transitioned to our own kind of methods, we discovered that we would do quite a lot of chunking overkill. So in a Township table, the chunk is just a grid on the map that contains all the data for all of the assets, dynamic and static, and all things in between. So at the beginning, we were chunking up everything. So the Unity terrain would be chunked up, and that would have to be loaded and unloaded. And that turned out to be like quite a large burden on performance. And it's something that we found wasn't a good idea. So we started to smooth it out. And this is the tool. What it needed to do was allow for really quick and easy modification of the world and support different people working on it. So those were the two things that it really needed to hit. It was super important for someone to be able to go in, make a change, and then send it back without interfering with anything. And this is it, right? It's a list view, because that's how every single tool in the world starts out, as a list. And because we only had around like 64 to 128 chunks in the beginning, that wasn't that big of a problem, because the list is easy to use. It had a search function. That's fine. And it was usable. It did the job with that number of chunks. But of course, things change over time. And 6 years later, the world streaming tool is kind of now the backbone of making the entire game. It's become this really big thing that's tied into a lot of the systems. And because of our need for optimization and hitting that really high VR frame rate that we require across 2 platforms now, it's gone through this massive transformation. It's still loading and unloading for performance, but it's also managing a bunch of custom and procedural content that's coming into the game. And it facilitates almost everything. So networking, batching, instancing, and saving of everything. And that's very robust and awesome. But because of this, there are so many more considerations in place that we need to think about when we're building out content. So there's art considerations on a density basis. There's level design, things that we need to keep in mind for specifically loading content. And then engineers have to worry about saving serialization and networking in an environment where something needs to be talking to something else, and it's either loaded or unloaded. It's very mind-breaking sometimes. And this is it. It's no longer a list, which is awesome, because a list view would suck because we have 4,000 chunks, and that's an optimization thing. So this is the tool. It's the overworld mapper, which is hooked into everything else. It handles the 16 kilometers squared of the overworld. You can drag select chunks. You can load in specific chunks at a time. You can save to it. You can load specific assets in it. It does a lot of stuff. And recently, I mean yesterday, I learned that there's a feature to assign specific chunks to a specific area and give it a name, and then load in that area, and it does everything automatically. It's magical. And I wish I knew that a couple of months ago, but now I do, which is great. So this also is tied into our forest and infinite cave generation systems. And of course, the little red square here shows the scene view camera. So you can easily identify where you are in the map with nothing loaded in, which is awesome. And you can load stuff around you quite easily, which is incredibly handy. So the world streaming tool also manages the chunk performance stuff, right? So super easy to make them, the custom chunks specifically, and easy to find them because they're not available in the kind of overworld mapper, but it's easy to kind of pinpoint where they are and load them in. And it allows us to preview the baked state of the world, which I'll talk a little bit more about later. It also has a landmark loading implemented, so that uses amplifiers imposters, which is also a very good tool that you should check out for these kind of things. And it just, in general, helps us maximize the performance to maintain that VR frame rate. So save chunks and batch data. Save data in our system is the process of creating an area and saving our work to specific chunks. So we can load a chunk, add, move, and remove dynamic and static assets, and save those to the loaded chunk. So if we reload that chunk later down the track, we can then select each asset and continue iteration without any issues. And then any changes to the original prefabs, as usual, if we were to change like an amount of branches on a tree, that'll still propagate throughout all of the instances of that tree. It won't get baked down or anything. So it still maintains that prefab functionality, which is awesome. And then on top of that, all the assets that we use when we're building out an area include the specific configurations for every platform that they need to build to. So a tree, for example, when loading it, when it gets baked down for quest, it's lower poly. It knows about any effects that it needs that are different to the PC counterpart, and it'll do that so we don't have to. So it knows everything off the cuff, which is awesome. The streaming tool also allows us to view that batch data, which is awesome. So it shows the output of our game's baking and batching processes. And batching for us means that meshes are merged, materials at lists, collision objects are optimized, and assets are cleaned up for their specific platforms. So the batching process also allocates shared asset pointers to different chunks. So for example, if a large portion of terrain is technically at its pivot point in chunk A, but largely overlaps in chunk B will still know that that terrain piece is overhanging and loaded in, even though it doesn't belong to that chunk in the save data. So it figures that all out for us. And then being able to preview that batch data allows us to debug any problems that happen in the editor that are kind of platform specific, because we can see it how that platform would, which is super useful. Now I'm going to tell you some of the weird things that happened along the way. So during our procedural forest, when we were working on that, we found a bunch of issues that confused us all and sent the team on a wild goose chase. So enemies were sometimes invincible, sometimes trees were buried or floating, and enemies sometimes teleported, causing like a Matrix-esque deja vu effect. We looked at enemy pathfinding, at the way the procedural generation system was spawning objects, whether or not the nav mesh was being generated correctly by the procedural generation system. We looked at everything, right? We tried to figure the thing out. Until one day we came across some blueberries and apples, which were floating and mysteriously in a straight line. And the only straight line that would really exist in that kind of generation system are chunk boundaries. So the XZ axis of the position of those objects. So they were being clamped by the chunks at serialization time. So enemies were invincible because on the server they weren't where the client saw them. Trees were floating or buried because they snapped to the terrain on the server, but were then offset on the client as a result. Enemies would walk in the air for the same reason. I'm sure we were clamping for performance reasons, but we ended up searching for new problems rather than that fundamental clamping issue. From the team, I wasn't around at the time, but I hear it was like Murder on the Orient Express, but for game devs. In another instance, early on in the game development, we started populating the world with more mobile enemies that kind of posed a stronger threat to the player. And as a part of the chunk save data, we can place enemy spawners that keep track of their spawned population to manage the repopulation of all the enemies. But we also wanted them to be able to wander off and leave a chunk, particularly if they were chasing down the player, so we could maintain that chase. And if the original spawner deloaded because they got too far from the chunk, we wanted that to persist. So we ended up allowing the enemies to leave their local population, deregistering themselves from that if the enemy left the chunk, and then while they were away, their kind of origin chunk was deloaded. So the population would then act as if there was a free spot and it could refill it, right? When it like rolled the right numbers to respawn, it would do it because it was a free slot. So even though it seems obvious now, what we didn't account for is that it's very likely that the enemy will wander back to where they were or not wander that far at all. So the implementation caused like a viral infection of enemies, as it would leave their population and the population would spawn another one. And this would just snowball until areas of the game were just coated with enemies. It was a ridiculous time. And of course, we only found out about this after we released it. So the peaceful plains, where they're supposed to go for a lovely walk, became a complete slaughterhouse. And if you take a look at that image, you can see there's a whole bunch of dots in the distance of enemies just hanging out. So it was a wild time for everyone involved. So the lessons that we learnt. What did we learn? In a big way, we learnt that a tool can govern the means at which developers work on the game. So what does that mean? We initially thought that we would be building this tool and we could create an environment that would be the perfect design in our minds. And then the tool would do the hard work and optimize it so that it would, run at an acceptable frame rate. But of course, that's very pie in the sky thinking. And instead, the result was that instead of that utopian one-way relationship of us feeding stuff in and then us getting a good result, instead, everybody on the team has to consider optimization in everything they do, which, in retrospect, makes a lot of sense. But you always try to build the perfect tool, right? So for designers, they need to keep any of the really fast-paced, high-risk activities away from the chunk corners, because when they're in those corners, they're loaded in a lot more frequently, and we might overflow the CPU with tasks of just loading gameplay stuff constantly. So when we're building out new areas, the designers really need to think about the placement of those really intense activities to make sure that we're not bogging down the frame rate. Artists need to worry about the asset density per chunk. So we don't want to completely flood the world with assets. We don't want to have a large amount of dense chunks in the same area. We need to consider all of those things in optimization to make sure that we keep that frame rate high. The tool isn't magical and doesn't do that for us, which is unfortunate, but a reality. And for engineers, they need to consider how items and objects reference each other, right, and listen to each other, because they can be loaded and unloaded. So everything needs to be managed in a way that makes sense and persists indefinitely. So it's a much bigger task for engineers to kind of do simple things to ensure that it works across everything. I was asking our CTO, Joel, who was awesome. I was like, what should the final lessons of this talk be? What, have you got anything in mind? And he was like, no, there is no final lesson. There will never be a final lesson. It's always what we do next, which is awesome and very true, because this is an ongoing process. The game's still live. We're still building stuff. Everything can be better at any point in time. So improvements in our pipeline is something that we're looking at. So the way we do baking, we build, and all the tooling optimizations that we can make in regards to the pipeline. It currently takes like a really long time to do that process, and there's always room to improve. And that's something that we've started to do, right? So in the past few months, we've been moving our build processes to the cloud in a way that frees up a lot of resources locally, so iteration time becomes a lot faster. Performance-wise, we would love to build tools for identifying those kind of dense, heavy areas of the map. So if we're building things out, we can easily pinpoint where an issue might be faced. So then we can more easily go in and kind of hit those things before they happen. Whether that's like too much mesh data in one specific area or some lighting issues that might be occurring in another area. Just those common things that can be easily identified. Like if we can automate that, that's so good. And then just having generally better tools for finding where static assets are used throughout the world, a better integration of toolbox style world building, because currently the system as it stands is us just kind of dragging in prefabs from the project window and then kind of arranging them. So having easier ways for people to find the prefabs that they need, the meshes that they need, the terrain tools that they need, everything like that in an easy to access tool is something that would definitely speed up our iteration time. And I think that's the final lesson. There is no final lesson. And all the decisions you make when you're building out a game really do have that butterfly effect and will kind of ripple through everything you do ongoing. Who knows what the tooling would be like if we remained with Sector? It would be, I assume, very different. And that's kind of it. Thank you so much for listening to what we have to say. I look forward to giving some more talks with some other people in the future. We have a lot of weird, interesting stuff that I think people will enjoy. So yeah, once again, thank you for listening. Hope you have a good one.